On February 18, 2025, NASA made an announcement that sent ripples of concern across the globe. Asteroid 2024 YR4, a celestial object hurtling through space, had a 3.1% chance of colliding with Earth. This might sound like a small percentage, but in the world of astronomy, it was a blaring siren. It meant that this asteroid had the highest probability of impacting Earth ever recorded for an object of its size. The date of this potential impact, 2032, a mere 7 years away. Suddenly, the world was on high alert, holding its breath as scientists scrambled to gather more data. The asteroid, first spotted in late 2024, quickly became the focal point of intense observation and analysis. The future, it seemed, hung precariously in the balance, dependent on the trajectory of a rocky visitor from the depths of space. The initial observations painted a concerning picture. Although not astronomically large, Asteroid 2024 YR4 was substantial enough to cause significant damage if it were to hit Earth. Its size, estimated to be around 177 feet in diameter, drew comparisons to iconic structures like the Leaning Tower of Pisa. The potential energy it carried, a consequence of its mass and velocity, was staggering. Early calculations suggested an impact could release energy equivalent to about 8 megatons of TNT. To put that into perspective, that's over 500 times the energy released by the atomic bomb detonated over Hiroshima. The world held its breath, hoping for good news from the observatories, where every telescope was aimed at the skies, meticulously tracking the asteroid's every move. As the global scientific community turned its attention to 2024 YR4, the saying "knowledge is power" rang truer than ever. Each passing day brought with it new observations, refining the projected trajectory of the asteroid and with it, the calculated probability of an impact. Almost as quickly as the initial alarm bells had sounded, they began to soften, replaced by a more cautious optimism. On February 19, 2025, NASA announced that updated calculations based on the latest observations had significantly lowered the probability of impact. The new estimate, a 1.5% chance of 2024 YR4 colliding with Earth. While still a cause for concern, this revised figure represented a dramatic drop, effectively halving the initial risk assessment. By February 20th, further refinements, fueled by relentless data collection, painted an even more reassuring picture. The probability of impact had plummeted to a mere 0.28%, or a 1 in 360 chance. The initial alarm, while understandable given the high stakes, seemed to have been a false one, a stark reminder of the dynamic nature of astronomical predictions. This rapid evolution in our understanding of 2024 YR4's trajectory underscored the critical role of continuous observation and data analysis in assessing potential threats from space. It became a real-time demonstration of how science, armed with data and driven by collaboration, could effectively respond to potential cosmic crises. Despite the reassuring news of a significantly reduced impact probability, the world remained captivated by 2024 YR4, eager to understand what could have been. The asteroid, though not large enough to cause a global extinction event, still packed a punch capable of inflicting significant regional damage. Its potential impact, had it occurred, would have been a stark reminder of our planet's vulnerability in the vast expanse of space. Scientists estimated that 2024 YR4, if it had struck Earth, would have released energy equivalent to approximately 8 megatons of TNT. To put that into perspective, imagine the force of over 500 Hiroshima atomic bombs detonating simultaneously. The immediate impact zone would have experienced unimaginable devastation, with a shockwave radiating outwards, leveling structures, and irrevocably altering the landscape. The long-term consequences of such an impact would have been equally severe. The massive release of energy would have lofted enormous amounts of dust and debris into the atmosphere, potentially triggering a nuclear winter effect. This phenomenon, characterized by a prolonged period of reduced sunlight and global cooling, could have had devastating effects on agriculture, ecosystems, and human societies worldwide. The close call with 2024 YR4, even with its diminished threat level, served as a potent reminder of the importance of planetary defense. It underscored the need for continued investment in early detection systems, deflection technologies, and international collaboration to mitigate the risks posed by near-Earth objects. The story of 2024 YR4, though ultimately one of receding danger, highlighted the crucial role of vigilance and preparedness in our cosmic neighborhood. The incident served as a global wake-up call, prompting a renewed focus on our ability to detect, track, and potentially deflect celestial objects that might pose a threat to Earth. Around the world, telescopes great and small had pivoted to focus on 2024 YR4, their observations feeding into a global network of data sharing and analysis. This collaborative effort involving scientists from numerous countries demonstrated the power of international cooperation in the face of a potential planetary threat. The 2024 YR4 incident also underscored the importance of upcoming missions like NASA's Near-Earth Object Surveyor, slated for launch in 2027. This space telescope, specifically designed to hunt for potentially hazardous asteroids and comets, promises to significantly enhance our ability to detect and track these celestial wanderers, giving us more time to react and, if necessary, intervene. The close call with 2024 YR4 served as a potent reminder that our planet exists in a shooting gallery of cosmic debris. It highlighted the need for continued investment in research, technology, and international collaboration to ensure our planet's safety. For in the vastness of space, knowledge is not just power, it's our best defense against the unknown.